So I'm Mario, and today I'm going to be presenting on my chemistry honors video, and I'm going to start off with the equation that was given to me, which was carbon monoxide plus nitrogen oxide as our reactants, and our products being carbon dioxide and a atom of nitrogen. Now I'm going to start off by breaking down each atom, and it's each specific atom. First, I'm going to start off with carbon. Carbon has an atomic number of 6, an average atomic mass of 12.01 average mass units. Carbon's group number is 4, and period number is 2. And the family for carbon, there is no specific family for carbon, and carbon's electron configuration is 2s squared, 2p squared. Now oxygen. Oxygen has an atomic number of 8 and an average atomic mass of 15.99 average mass units, and the group number is 6, while the period number is also 2, and this one also does not have a family, and the electron configuration is 2s squared and 2p to the 4th. Now nitrogen. The atomic number for nitrogen is 7. The average atomic mass is 14 AMU, and the group number is 5, while the period number is again 2. This molecule also doesn't have a family, and the electron configuration is 2s squared and 2p cubed. Now, moving on to balancing the equation. As you can see on the left, the original equation was not balanced because there was not an even amount of nitrogen atoms on both sides of the chemical equation. So to change that, I had to add a coefficient, which is the only way you can actually change a chemical equation, by adding coefficients. So by adding the coefficient of 2 in front of nitrogen oxide, I was able to get the amount of nitrogen atoms on both sides equal. But in doing that, I also changed the amount of oxygen atoms on both sides. Instead of being 2 and 2, 2, 3, and 3. And the amount of carbon atoms stayed the same. Now the enthalpy values. For carbon monoxide, it was negative 110 kilojoules per mole. And for nitrogen oxide, it was positive 90.4 kilojoules per mole. And for carbon dioxide, it was negative 394 kilojoules per mole. And since this specific molecule of nitrogen is in its natural state, it is 0 kilojoules over moles. Now, enthalpy calculations. So how this is supposed to work? It's products minus reactants. So it was so for the products, only negative 394 was used, because negative 394 plus 0 is negative 394, and then I had to multiply 90.4 by 2, and then add that to negative 110, and then add those two together, subtract them, and end up getting negative 332.2 kilojoules per mole. Now, if there was 250 moles acting upon this, I just have to multiply negative 323.2 by 250, and that would give me negative 80,800 kilojoules. Now, 1 kilojoule is equivalent to 1,000 joules, so by multiplying that by 1,000, I get negative 80,800,000 joules, and this is an exothermic reaction because it is a negative. Now, the change in temperature. I have my joules, which was negative 80,800,000, the amount of water, which was 1,000 grams, and the degrees Celsius, the change in temperature. Okay, so now to find the change in gas, I had to multiply 1,000 grams by 4.18 joules over grams degrees Celsius times 21 degrees Celsius, which is the change in temperature. And 4.18 was specific heat capacity, which is basically the amount of heat it takes, the amount of joules or energy it takes to change 1 gram of water by 1 degree Celsius. And 1,000 grams is obviously just the mass of the water. As a result, I got 87,780 joules. Now, the latent heat vaporization is something different, which is basically just the mass again, 1,000 grams, times 220 2,260 joules over grams, which is the latent heat of vaporization, and that gives me 2,260,000 joules. And to find the total energy, I have to first add those two up. To find the total energy it would take to change the water into a gas. But then and we want to subtract that specific number from the total energy that we got before, which was negative 80,800,000 joules, and in the end that gives us negative 78,452,220 joules. Now we're not done yet. We actually have to find the temperature change. So we just plug it into that same equation, except now we're looking for a specific variable, and we have our answer. So we plug in for SQ, which is our answer, negative 78,452,220 joules, and we again use 2,000 grams, but this time we use 1.99 joules over degrees Celsius, which is the specific heat capacity of gas. And now we're looking for the change in temperature, so that's not what we're looking for. So that's technically like our x variable. So first off, we multiply 1,000 grams by 1.99, giving us 1,999 joules over degrees Celsius, and the reason for that being is that the grams cancel out, and then we divide both sides by 1,999 joules over degrees Celsius, and the joules cancel out on the other side of the equal sign, giving us negative 39,423.2261 degrees Celsius, which was our total change in temperature. And that concludes the video. Thank you for watching, and I hope this was helpful.